The company that makes Flaming Hot Cheetos has a problem. Some of their customers have complained that the company's 10-ounce bags of chips seem light, and they don't believe they're getting their money worth. The first thing they did was hire a statistician to find out how much their 10-ounce bags weighed on average. The statistician randomly selected 15 bags of chips from an assembly line. The mean weight of the 15 bags was 9.85 ounces, and the standard deviation was 0.12 ounces. The 95% confidence interval for the mean was from 9.61 to 10.09 ounces. In the distribution triad, the population is all the Flaming Hot Cheetos. And in this graph we did here for the S-dom is our sample, and for this graph we did the theoretical population.
So I'm going to teach you how to calculate the 95% confidence interval. So first what we do is we divide sigma by the square root of n. And we know that our sigma is 0.3 and our n is 15. And we get our standard error. Next you want to get our margin of error. And to do that, we multiply 2, which is our z-score, times standard error. Now, here's a formula for confidence interval, which is sample mean, which is 9.85, plus or minus the margin error, which is 2 times sigma divided by the square root of n. And that's how we got our 95% confidence interval for the mean, which was from 9.61 to 10.09 ounces.
And here is the logic behind our calculations.
Okay, so here on the graph are our confidence intervals, which is 9.61 to 10.09. We found the confidence intervals within the 95%, which is 2 standard deviations away from the mean. And if we wanted left and right, and if we wanted to find 68% of the, we would go ahead and just do 1 standard deviation left and right from the mean.
And here is how we address the customer's complaints about the bags not weighing enough.
The customers are correct. They're not getting their money's worth. You can see for this graph that there's a small percentage of people only receiving 10 ounces in their bags, but there's a lot more people who are not getting the 10 ounces.
If you wanted to make sure, then 95% of all the customers who bought a bag of Flaming Hot Cheetos got at least 10 ounces of chips. Here's what we did.
Since the customers are not receiving at least 10 ounces of chips in their bags, we then created a new theoretical population where our new mean would be 10.6 ounces versus 9.85 ounces.
And here's our logic behind our proposal.
So our logic behind our proposal is, since on average each bag will have 10.6 ounces, we had to have, if we move the standard deviation over, 2 standard deviations over, it would be 10 at the minimum of clients getting 10 ounces in every bag. So if you refer back to this one, 9.61 is at the lower end. So clients aren't satisfied, they're not getting at least 10 ounces. But if in this new theoretical population, clients will be getting at least 10 ounces in every bag that they purchase. So on average, what we would propose to the company is for them to actually make sure that their machines distribute at least 10 ounces per bag. So on average, 10.6 ounces per bag. So they'll actually get more clients happy and wanting to purchase more bags of Hot Cheetos because they'll be getting more than 10 ounces, 10.6 on average. So this would actually cover even a little bit more than 95% of the population getting more than 10 ounces per bag. So they'd actually end up making profit off of it because more people would want to come back and buy their bags. So we proposed this to the company and maybe they would take a look at it, and this actually is our theoretical population.